Welcome to The Explainer. Today, we're tearing down something pretty incredible. Right now, the whole AI race is basically sprinting toward massive data centers and endless cloud computing. But Project Aora, it's running in the exact opposite direction. We're going to go straight under the hood of a fully offline, multi-agent AI ecosystem that's designed to live entirely on your own hardware. Let's get right into it.
I want you to really think about this for a second. What if your AI partner literally never connected to the cloud? Not for processing, not for software updates, and definitely not for telemetry. We are talking about absolute digital sovereignty. That right there is the core premise of Project Aora. It's not just about running a local model for fun, it's about building an entire digital partner completely insulated from external networks. So here's our roadmap for today. 1. The sovereign AI ecosystem. 2. The 4 inviolable tenants. 3. Hermes and Odysseus explained. 4. The living file protocol. And 5. Total privacy, local hardware.
All right, kicking things off with Section 1, the Sovereign AI Ecosystem. So, Aora stands for Architectural Open Relational Architecture. Now, don't let the technical name fool you. This isn't just your standard run-of-the-mill chatbot. It is a full-blown multi-agent intelligence layer. This system can plan, build, monitor, do research, generate images, and actually evolve. And it does all of this 100% offline on your local machine. Operating at what the developers called the Aora v2 aspirational end state, the goal is basically to bring the massive orchestration power you'd usually associate with the cloud straight down to your local desktop.
Moving right along to Section 2, the 4 inviolable tenets.
Before we dive into the code, we absolutely have to understand the rules of the road here. These 4 tenets act as an unbreachable foundation for Aora. Number 1 is sovereignty. All computation is bound strictly to localhost 127.0.0.1. That's your machine's home address. Absolutely no data leaves. Number 2 is privacy by architecture. Zero telemetry is hardwired in. Number 3, cognitive liberty. This means you always hold the final override. The AI presents options, but it never commands you. And finally, number 4, constitutional AI. The system's behavior is governed by a core file called soul.md, which is kept completely safe from casual prompt overrides.
Listen to this guiding philosophy from the source material, because it hits the nail on the head. Privacy is a constraint that cannot be violated, not a feature to implement. In standard apps, privacy is usually just a little toggle switch buried in some settings menu. But in Aora, it's the physical and architectural bedrock. If a task can't be done privately, it just isn't done at all. Period.
Okay, Section 3, Hermes and Odysseus explained.
Let's look at Aora's division of labor, because it's essentially a dual-agent operating system. Think of Hermes as the hands. Powered by the Ornith Clun 19B model, Hermes is the one handling external execution, using specialized tools and getting the actual building done. Then on the other side, we have Odysseus. This is the mind. Odysseus doesn't execute code at all. Instead, it serves as your digital guardian intelligence. It handles cognitive partnership, long-term planning, and strategy. And these two are constantly working together in this continuous orchestration loop.
Now, this is where it gets really interesting. A crucial thing to know about Odysseus is this concept of productive friction. Think about it. Most AI models today are totally sycophantic, right? They just want to please you and tell you what you want to hear. But Odysseus is specifically designed with a guardian archetype. It values intellectual honesty way more than user satisfaction. It'll push back, respectfully but firmly, if you're misinformed or if you're heading down a flawed path. It's there to illuminate possibilities, not just hand you an easy, potentially wrong solution.
Next up, Section 4, the living file protocol.
So, how do Hermes and Odysseus actually remember things over time? Well, this brings us to their memory framework. The system uses a local Obsidian vault as its persistent hippocampus. Instead of relying on some opaque database locked in the cloud, Aora writes its memories and tasks as completely transparent markdown files. We're talking basic text documents saved right onto your hard drive. You can go in, read them, edit them, audit them anytime you want. It effectively turns simple files into a dynamic living brain graph.
Let's walk through how this actually builds into an orchestration loop step by step. Step 1, an agent generates some context or makes a decision. Step 2, a local embedding model, specifically Nomic Embed, processes that text. Step 3, it gets semantically indexed in a local vector database. And finally, step 4, the actual text is persistently saved directly in the Obsidian vault. This whole loop allows the agents to do semantic searches later on, instantly pulling up relevant historical context. Literally every interaction becomes a permanent, searchable memory.
Finally, Section 5, Total Privacy, Local Hardware.
16 gigabytes. That is the absolute strict VRAM ceiling of the target hardware for this project, an AMD Radeon RX 9060 XT. To put that into perspective, 16 gigs is pretty much a standard mid to high tier gaming setup today. Now this ceiling is exactly what enforces Aora's local privacy, but man, it creates a massive engineering challenge. You simply cannot load these gigantic models into memory all at once. In this ecosystem, the physical hardware boundary strictly dictates the software architecture.
When you are operating entirely offline, memory allocation is a total zero-sum game. Let's break down the budget. Hermes takes up about 5.1 gigabytes. Odysseus needs 6.1 gigabytes. That Nomic embed model we talked about, since it's constantly active for the memory system, it needs about 320 megabytes. Oh, and you absolutely must reserve a 1.5 gigabyte safety buffer, just so your entire operating system doesn't completely crash.
So, because of those incredibly strict limits, resource conflicts are totally inevitable. Say you want to load up Comfy UI to generate some images. Well, that requires over 8 gigabytes of VRAM all on its own. If you try to run that alongside Hermes or Odysseus, you instantly breach your 16 gigabyte limit. These massive agents simply cannot all be awake and sitting in memory at the same time. The system literally has to play traffic cop and orchestrate who gets the spotlight at any given moment.
And solving that traffic jam requires this really ingenious 5-phase handoff protocol. Say you need to transition from Odysseus doing some deep thinking over to Comfy UI rendering an image. The system executes a highly choreographed sequence. First, it drains the current tasks, which takes about 2 to 4 seconds. Then it unloads the active model from VRAM, taking up to 12 seconds. Step 3, it starts the new service. Step 4, it loads up those heavy, flux image models, which can take anywhere from 15 to 30 seconds. And finally, it spends a few seconds warming up the inference engine. It is a beautiful hardware dance designed to maximize capability without ever blowing past that 16 gigabyte limit.
Which leaves us with this massive question. As Project Aora continues moving toward its aspirational Aora v2 end state, it really challenges us to rethink our entire relationship with AI. I mean, what does true, unified digital sovereignty look like for your future? When your AI doesn't serve a massive cloud provider but serves only you. When it runs entirely on your own hardware, guarding your privacy down to its very architecture, and actually pushing back on you with productive friction. How does having a partner like that change what you can build? It's a completely fascinating paradigm shift, and honestly, one that is absolutely worth paying attention to. Thanks so much for joining me on this explainer.